This is a piece of paper. But it's not just any piece of paper. This is a piece of A4 80GM paper. And it is 0.1 millimeters thick. And you know what I'm going to do? I'm going to fold it. Then I'm going to fold it again and again and again. The question is, how many times can I fold this piece of paper?
My Americana ain't no use living for tomorrow without a doubt. We're all missing out. It's all in my Americana. Got my 99 cents. I sold my blood for rent. He said, she said that the whole world's gone to shit. Don't try and tell.
Back over at NASA, our team is finding out that folding a football field-sized piece of paper isn't exactly a breeze. To achieve double digits, the paper is too heavy for the team to lift themselves, so they stick a fork in it.
Drive in, drive in.
Whoa.
That is a definite 10.
Okay, so I can only fold this piece of paper 6 times. That's just the way it is. If I could physically fold this piece of paper 42 times, I would actually reach the moon.
But never again, back on our grind, you know what it is. Yeah, this is our year.
What you're seeing here is called exponential growth, right? It's doubling every time I fold it. In fact, it's increasing by 100% every time I fold it. Now, there's another thing that also exhibits exponential growth, and that's the coronavirus. Understanding the coronavirus is all about understanding the log scale. If you understand the log scale, then you understand the nature of the virus and why it's so important that we contain the virus. Now, the log scale, we've seen it a lot recently. We've seen it in the news. People talk about the logarithmic scale, and it sounds very complicated, but it really isn't. And that's why I use this paper example, because folding this piece of paper is the perfect real-life example of a log scale in action. Each fold is a unit on the log scale. So on fold 0, I have 1 sheet of paper. On fold 1, I have 2 pieces of paper. On fold 2, I have 4. And on fold 3, I have 8 pieces of paper. Now, this is called the log base 2 scale. In reality, we don't really use the log base 2 scale. We use actually the log base 10 scale. And before you think that's even more confusing, it's not. It's actually very, very easy, probably even easier to understand than the base 2 scale. With a base 10 scale, instead of doubling each time, like a piece of paper, you multiply it by 10. So every time it's increasing by 10 times, not 2 times. And actually that's easier to understand because all you do is count the number of zeros to understand where you are on that scale. So it goes something like 1, 10, 100, 1,000, 10,000, and so on. There are actually so many different applications of the log scale that we don't even notice in everyday life, like the volume on our stereo, acidity levels, the Richter scale that we use to measure earthquakes, and radioactivity. We use logarithmic scales to measure those things because actually it makes much more sense when you do that. And the reason being is that it just puts everything into proportion and makes things comparable, makes things easier to understand. I mean, to think about it like a stock, a penny stock, right? If a penny stock rose to 2 cents, that means that it doubled and you got 100% return. But say that same stock was worth 50 cents and it rose to 51 cents. That's not a 100% return, that's a 2% return. Yet, if you put that on a linear scale and you measure it, it looks like it's the same amount, but it's not. One is vastly bigger than the other. And that's why we need the logarithmic scale. So when we are looking at the coronavirus, what we're looking at is the growth rate of the coronavirus and trying to contain that and slow down the growth rate and put it into reverse. And that's why you need a logarithmic scale, because it shows you if there is a decline in the growth rate. to leave on a positive note, I'm going to leave you with a clip that I filmed on my smartphone about a week ago. And you're going to see it. Just to add a little bit of context, there was a reason why this was happening. And it was because there was an old lady on that street who had just turned 100 years old, and she was standing on the balcony.